Alright, now we are going to look at how we can construct quadratic equation. Now the last time we stopped at how to use quadratic formula to solve quadratic equation. So we are going to look at how we can construct quadratic equation. We can construct a quadratic equation by using the formula x squared minus sum of root x plus product equal to 0. Now the formula is on the board. The formula we can use to construct a quadratic equation is x squared minus sum of roots x plus the product of the roots equal to 0. So this is the formula you can actually use to construct a quadratic equation. With this formula, you can actually construct any quadratic equation of your choice. So this formula helps you to construct a quadratic equation. Now let us look at the examples we have on the board. Now look at the first example we have on the board. Find the sum and the product of the root of the equation. Find the sum and the product of the roots of the equation. Now before I solve that question, there is something I also want you to know. If you want to construct a quadratic equation, I told you that you use x squared minus sum of root x plus product of roots equal to 0. Now note that your sum of roots, this can also be written as x squared minus, take the sum of the root to be alpha plus beta x, then plus the product to be what? Alpha beta equal to 0. So that means, in other words, the sum of roots is equal to alpha plus beta, and product of roots is equal to alpha beta. If we compare this now with our quadratic equation, recall that our quadratic equation is of the form ax squared plus bx plus c equal to 0. Now if we compare this, remember, if I have something like this now, I can simply divide through by what? By a. So if I divide through by a, I have ax squared divided by a plus bx over a plus c over a equal to 0. So a cancel a. We now have x squared plus bx over a plus c over a equal to 0. If we compare this equation and this equation right here, if we compare these two equations together, we can say that b over a, we equate it to minus alpha beta x. Okay, so I can just say that my bx over a equal to minus bracket alpha plus beta x. So this x cancel this x here. I now have that what? I can take this minus. The minus is multiplying this alpha beta, and of course when we multiply both sides by minus so that this minus goes off, I now have that minus times minus bracket alpha plus beta equal to what? Minus b over a. It therefore means that our sum of roots alpha plus beta is equal to minus b over what? Over a. I believe you can see how all these things are being derived. Let us see how we can also get for our product of roots now. Now remember the equation I gave you earlier on, which is x squared minus alpha plus beta x plus alpha beta equal to 0. That was the initial equation I gave you. If we follow that equation, which I gave you as x squared minus bracket alpha plus beta x plus alpha beta equal to 0. Then I also give you another relationship, that x squared plus bx over a plus c over a equal to 0. Now I've told you what the sum of the roots are, but I have not given you what the product of the roots are. So in that case, the product of the roots, which is alpha beta, the product, which is alpha beta, will be equal to what? If you equate these two expressions here, you have alpha beta is equal to c over a. So that means our alpha beta is always c over a. So if you look at this question now, which is given to us on the board, we're told to find the sum and the product of the root of the equation. So what you have to do is to follow exactly what I have just done now. That is the approach you are going to use to solve this question. Now, the first question we have there is, we have question A. Let us see the solution to question A. Solution. Question A, you have 5x squared minus 4x minus 9 equal to 0. So what I will do is, the coefficient of x squared is 5 here. So I'm going to divide through by 5. So if I divide through by 5, I have 5x squared over 5 minus 4x over 5 minus 9 over 5 equal to 0. So this 5 cancel this 5 here. I have x squared minus 4x over 5 minus 9 over 5. Remember the equation I gave you earlier on, that x squared minus the sum of roots, which is alpha plus beta x, plus alpha beta, which is product of the root, equal to 0. From what we are asked to do now in the question, we are told to find the sum and product of the root. So the sum, my sum is what? Is alpha plus beta. Now if you compare these two equations here, equation star and equation star star, if you compare them now, you find out that these two symbols, you have minus here, you have minus here. So remember that alpha plus beta, from what I told you, alpha plus beta is what? Minus b over a. And what we have here for the sum of the roots here in the equation is actually minus 4 over 5. If I slot it in, I have minus what? Minus bracket minus 4 over 5. That is what we're going to have, which obviously you know the reason why it is minus minus. The formula for sum of roots is minus b over a, and there is a minus here. So in that case, the minus, this minus here is what you are seeing here. And this minus here for the minus 4x over 5 is what you are seeing inside the bracket. So finally, the sum of the roots, alpha plus beta, gives us minus times minus is plus. So that gives us 4 over 5. Okay, so the sum of the roots is 4 over 5. Now let us get the product of the roots. To get the product of the roots, already we know that alpha beta is the product of the roots, which is equal to what? Is equal to c over a. And if you compare this star equation star and star star star, you find out that your c over a here, which is this one, is actually negative. If you slot it in there, you have your c over a becomes what? Minus 9 over 5. Because that is your alpha beta, this is your product, and this is your product. So you equate them. If you equate them, you have minus 9 over 5. So that is your alpha beta. So alpha beta is equal to minus 9 over 5. So that's all about that particular question. That is how you can actually look for sum of roots and product of roots of a quadratic equation.